Alright, Common Core Algebra 1. So we have spent quite a bit of time factoring and doing quadratic formula. Today is going to be one of the times we're going to see where they apply with a little more detail on our quadratics, in particular how we graph a quadratic. So today, using a quadratic equation, we're going to find the x-intercepts, the vertex, axis of symmetry, and y-intercept. So if any of this stuff sounds unfamiliar to you, it has been quite a while since we've done it, you're going to want to go back and check out the first video we did this section on quadratics, or this chapter on quadratics, which was called Introduction to Quadratics, Graphing a Quadratic. Okay, so jumping right into it, first thing we're going to have is what's called the intercept form. So the whole video is going to be about intercept form. And it's going to look like this. Y equals a, some number a, times the parentheses x minus p, where p is a number, times the parentheses x minus q, where q is a number. Okay, the other way we could see it is maybe in function notation, which would look essentially the same way, except we change that y to an f of x. Okay, either way. Now, when we have this, our x-intercepts are always going to come from p and q. Okay, a big thing to notice here is that this is a minus sign, this is a positive. So if we have an example like this, where it's x minus 3, our x-intercept is actually 3, 0, that's our p value. And our q here has got to be the opposite of this. So if this is plus 4, that's actually negative 4. So our second x-intercept here is negative 4, 0. Okay, to find the x-intercept, suppose it's not given to you in that form, what you're going to want to do is factor that. Okay, the other thing you can do is quadratic formula. Now, it doesn't matter which one you do, either way, it should help to get into intercept form. Okay, there are always going to be a possibility of 2, 1, or 0 x-intercepts, and if you remember when we talked about quadratic formula, same idea. There was always 2, 1, or 0 solutions to the quadratic formula. Whatever your solutions are in the quadratic formula are also what are called your x-intercepts. Now, because there could be a different an option of 0 x-intercepts, that means that there's not always an x-intercept. Okay, so an example of that, and in this one I'm going to say factor because this one's a fairly simple one to factor. Going back to remind you about factoring, we take the factors of negative 4 that add up to negative 3, and because this first number is 1, we can just write it in two parentheses. So we'd have x minus 4 and x plus 1, because negative 4 times 1 is negative 4, which we want for this last spot, and negative 4 plus 1 is negative 3, which we want for that middle spot. So because of that, that tells us that our x-intercepts are 4, 0, remember take the opposite here, and take the opposite, negative 1, 0. So having the opposite is always a big part. Probably want to write that down somewhere. It's always going to be the opposite. Okay, so that's how we find the x-intercepts. Next thing we're going to talk about is how to find the vertex. And to find the x-coordinates, we have to do two things. The vertex is going to be some point, where we have an x-coordinate and y-coordinate. Remember, it's either the max or the min, depending on which way our graph opens. To find our x-coordinates, we're always going to plug in x equals negative b over 2a, where this a and b are the same values that we used when we did our quadratic formula. After we have our x-coordinate, we're going to look for our y-coordinate by taking this value, whatever it is after we simplify it, and we're going to substitute it back in to the original equation. Okay, so to do that, an example here, if we want to find the x-coordinate, well, we know that a is negative 2, b is 12, and c is negative 7. So we start by plugging into that formula negative b over 2a, which you just saw on the last slide, which means we have negative 12 over 2 times negative 2. Simplifying the correct order, negative 12 over negative 4, because we do this multiplication in the denominator first, gives us a positive 3. So we know that our x-coordinate is 3. Now we need our y-coordinate. And we do that, second step, by taking this value for 3. Remember, this is your x value, and we're going to plug it back in here. So y equals negative 2. I'm going to change the x to 3. It's substitution. Something comes on, something comes off. Plus 12, substitute x for 3, minus 7. And I can plug that all into the calculator at once, provided, again, you're not using your silly little cell phone calculators. You're actually using a real calculator. It will do order of operations correctly for you. And if you plug that in and simplify, you get 11, which means up here our vertex is going to be 3 was the x-coordinate we found, 11 was the y-coordinate. That is the vertex. So we did negative b over 2a to find 3. We took that, we substituted it back in for x, and we got 11 for y. That's our coordinate, either our max or our min, depending on whether our vertex or our parabola opens up or down. Okay, last thing we're going to talk about then is how to find, or two more things actually, the axis of symmetry. Now, the axis of symmetry is really easy. The axis of symmetry and, big thing here, the x-coordinate of the vertex, they are the exact same thing. So to find the axis of symmetry, you're doing the same thing, negative b over 2a, and we're going to write our axis of symmetry as an equation. Remember, it means it divides our parabola in half. Everything is going to be the same on left and right of that line, hence symmetry. And we're always going to write it y equals, now this a should not actually probably be a, because this is going to be the part negative b over 2a. This comes from that. It's always going to be x equals negative b over 2a. Okay, this is probably a better equation to write. Let's not do that one. Alright, so axis of symmetry is done. If we look at that, it's always going to be the x-coordinate of the vertex. So our axis of symmetry for this first example, x equals negative 3. For the second one, x equals negative 7.5. And for the third one, x equals 6.23. Those would be our axis of symmetry. We would draw a vertical line through each one of these x coordinates for each different parabola. And now the last thing we're going to find is what is called the y-intercept. And your y-intercept is always going to be 0 and your c value. So whatever the c value is from the equation, again, same place we'd get c when we talked about the quadratic formula. Nothing to it, no computations to do, no math to do. We can just look at our equation and figure out what it is. So for example, our c value on the first one is negative 7, so that means our y-intercept is 0, negative 7. The second one we have plus 3, so our y-intercept is 0, 3. And the last one is plus 11, so 0, 11. Those would be your 3 y-intercepts. Okay, the other option to do here too is it's always, you'll notice, x equals 0. So we could plug that in, simplify, and get out our y value. Okay, so that is it for this lesson. We talked about quite a bit. Make sure you got all of these notes. Go back and get them if you didn't. If you are not completely sure about how we graphed each one of these, I would go back and watch the Introduction to Quadratics, how to graph. All right, we'll see you next time.